Thank you, Joel. So our next presentation will be by Chris Lannon from the Great Basin Unified Air Pollution Control District, and he will be presenting on behalf of Mr. Ted Shady, who is also from Great Basin but was not able to join us today. So I'll read Ted's bio so you're familiar with him. So Ted is the Air Pollution Control Officer for the Great Basin Unified Air Pollution Control District. Great Basin regulates the air quality in Alpine, Mono, and Inyo counties. Ted has worked with the district since 1990 and has been the Air Pollution Control Officer since 2004. Much of his efforts at Great Basin have included research and development to control PM10 emissions from the dried Owens Lake bed, which prior to 2006 was the largest source of PM10 emissions in the United States. Ted is a registered professional civil engineer and has a Bachelor of Science degree in Civil Engineering from Notre Dame and a Master's degree in Civil Engineering and Water Resources from the California State University, Long Beach. Please join me in introducing or welcoming Chris Lannon.
Good morning, everyone. My name is Ted Shady, and I'm the Air Pollution Control Officer for the Great Basin Unified Air Pollution Control District in Bishop, California. I am really happy that you are all here today for this PQAO training. When I heard about the training some time ago, I knew that this was sort of the perfect thing for all of us to work on. The monitoring efforts that we do, the monitoring efforts that you do in the field are really form the basis for everything that comes after your data collection efforts. As you'll see in the presentation today, it's my theory that with regard to policy and regulation, if the air pollution isn't measured, it essentially didn't happen. So what you do in the field is very important, and without the large group of dedicated field technicians that we have throughout California, none of the control efforts, the great progress that we've made in controlling air pollution over the past few decades would have been possible. So I know I appreciate your efforts, and I apologize for not being with you personally today, but Chris Lannon on our staff will be making the presentation. Thank you very much.
Ready for the presentation? There we go. Okay, so this is Ted's presentation, as he mentioned, and I'm the backbencher that's been put on the spot to make it for you today. So this is a picture of a dust storm on Owens Lake. But the point is that Ted wants to make is that it all starts with you. It all starts with the people who actually collect the data. So how did that happen? Let me back it up. Yeah, and as he mentioned, if it's not measured, then it didn't happen. I mean, it doesn't matter what the event looks like. If you don't have any data to show objectively that something occurred, then it didn't happen. This is Ted's view of air quality data. It gets pushed through a hole into another universe, and no one knows where it goes or what it's used for. Occasionally something comes back through the hole, and we wonder, is anybody out there? And what happens to the data as it's pushed to higher levels? Or why are we here? The data that each of us collects has many, many influences on policy, regulations, politics, economics, law, and public opinion. Air monitoring data, as we all know, properly collected and supported, makes the case. This shows the state of California, and then the middle picture shows the Owens Valley planning area in the yellow color, and the Owens Dry Lake bed itself is the brown in the southern part of that picture. And then on the right is Owens Lake, and that's the so-called regulatory shoreline. So 100 years ago, the 110 square miles of Owens Lake was one of the largest natural lakes in California. It was a saline terminal lake, so water only left the lake through evaporation. In the early 1900s, the city of Los Angeles was looking for water supply for its newly incorporated San Fernando Valley community. So the city of Los Angeles began buying up the land in the Owens Valley surreptitiously, posing as gentlemen farmers so they could get all the water rights. Finally, they purchased basically all the land in the Owens Valley, and then in 1913 they began construction, or they completed construction of the Los Angeles Aqueduct. The aqueduct is basically a concrete river that takes the water from all the tributaries of the Owens Lake down to the city of Los Angeles, 223 miles to the south. So by the mid-20s, this is what the lake looked like. As a result of the water diversions, southern Owens Valley experiences some of the highest PM10 concentrations ever measured in the United States. Prior to the start of implementation of dust controls in 2000, Great Basin APCD estimated that the lake bed emitted about 76,000 tons of PM10 annually, or about 7,000 tons of PM10 on a peak storm day. The interesting thing is that the background PM10 concentration in the Owens Valley is about 20 micrograms per cubic meter. Here are two views of the Owens Valley from the same aerial vantage point. The one on the right, you can see the Owens Lake bed. It's kind of washed out. But the one on the left is during a storm on a windy day. And you can see the valley is basically completely obscured by dust. So why is this dust a problem? Who cares? There's, frankly, quite a few people that live in the Owens Valley that say, oh, that's just geological material. That's healthy dust. That's not a problem. And they seriously wonder what all the fuss is about. Well, the PM10 values are very high. You all know the federal standard is 150, the state is 50. The significant harm to health level is 600 micrograms per cubic meter. In 2005, we measured 1,440 micrograms in Keeler and almost 4,000 at the shell cut monitor on Owens Lake. That's a 24-hour number. In 2005, EPA data shows that of the 10 highest PM10 concentrations in AQS, 7 of them occurred at Owens Lake, 3 of them occurred at Mono Lake, but basically all of them were within Great Basin District. In the Owens Lake's value, it's significant to note that the value of 4,000 was 5 times higher than the next highest non-Great Basin concentration, which was around 750. So the dust is being controlled. The city of Los Angeles is beginning a mitigation program being dragged screaming and kicking by the district. But this is one of the methods used for dust control. This is a flood irrigation pond. During the 90s, Great Basin did research at Owens Lake and resulted in the development of 3 approved best available control measures for mitigation of the lake bed dust. 1 was planting with native vegetation, 2, flooding with shallow sheets of water, and 3, application of a gravel blanket. 8 phases of work have taken place on the lake bed since 2000, and thus far, 500 miles of pipe and drains have been installed, 10 million cubic yards of grading has been performed, 3,500 miles of drip tube installed, 7,300 flood bubblers, and 75,000 acre-feet of water are applied to the Owens Lake bed each year. The bottom 2 pictures are construction of the pipeline. When the contractor showed up to start the process, they thought that their new fancy excavator would be able to go out on the lake bed because of its low ground pressure. And then it started to slip into the gelatin-like mess that's below. So that's the APCO, Ted Shady, standing on the excavator there. There have been significant decreases in both the number of PM10 exceedances per year and in the average PM10 values around the Owens Lake. You can see, for example, we look at Keeler, the number of exceedances, dirty socks, that's the red bar. We were having in 2000, we had about 32 exceedances, and then in 2008, we had 8. And likewise, the annual average PM10 level has dropped at dirty socks from about 375 to about 60. Pretty significant drop. Current Owens Lake dust controls consist of about 36.5 square miles of shallow flooding, 3 square miles of vegetation, 2 square miles of gravel, and about 1/2 square mile of sand fences, resulting in a total of about 42 square miles of the lake bed that have been mitigated thus far. Here's a satellite image of all the dust control measures that are currently installed on the Owens Lake bed. The cost of Owens Lake air pollution control is high. The city of Los Angeles claims to have spent about $1.2 billion on dust control since 2000. With 42 square miles currently controlled, the cost of controls is about $29 million per square mile. Annual operating costs, $25 million. Annual water replacement costs to the city are about $46 million. But the PM10 controlled is about 75,000 tons per year. The cost effectiveness, therefore, over the 20-year life is about $2,700 per ton, about half of what South Coast considers to be the top of the reasonable cost effectiveness pollution control. So it's not as expensive as it looks on its face. The district has developed a fairly innovative method for monitoring the emissions off the Owens Lake bed. The goal of this program is to ensure that only those areas that are severely emissive enough to cause an exceedance of the federal standard at the shoreline of Owens Lake get mitigated. So it's not just wherever the dust blows, you got to mitigate. It's only those areas that cause a significant impact at the shoreline. None of these controls would have been possible at Owens Lake without superior air quality data. At Owens Lake, the district has 12 continuous monitors for PM10, they're TOMs. We have 200 sand motion monitoring sensors called Sensits. We have meteorology we've monitored at 20 sites, and we have time-lapse video cameras at 14 locations. Every year we collect about 50 million data points that go into the dust ID model. The results of dust ID modeling, as I mentioned before, allow us to pinpoint those specific areas that cause or contribute to PM10 exceedances. Recent modeling has indicated that additional controls are going to be required in order to attain the standards at the shoreline. With the phases that we have in place, the 8 phases, we've got 42 square miles. Phase 7A is under construction currently. It's 3.1 square miles. We ordered an additional 2.8 square miles in 2011, an additional 3/4 of a mile in 2012, and so far that seems like that's all it's going to take. It'll be a total of 48.7 square miles. We've been involved in litigation over all these issues since 1997, when we first promulgated the first Owens Lake SIP. There were 2 lawsuits that were filed against the district, against Great Basin, in LA Superior Court, and they eventually were withdrawn by DWP. DWP appealed the 2011 order to the ARB, and the ARB found for Great Basin. DWP appealed the 2012 Great Basin fees to ARB, and a hearing was held in June 2013. We subsequently won that. DWP sued the district, the BLM, EPA, and the Forest Service in federal court, and that suit was then dismissed by the federal court. Great Basin sued the DWP for lack of payment, and DWP was ordered by the court to pay. DWP filed a cross-complaint in that case, but that was dismissed by the court. Great Basin also sued for penalties when they neglected to pay their fees, and we reached a settlement with the DWP. Pending, DWP has sued the ARB and Great Basin with regard to the 2011 order, and that's pending in court in Sacramento. That'll be heard in September. And then they've also appealed the 2012 order. The hearing was conducted in April, and we're awaiting the decision from the ARB. The point to all this is that in every single one of these actions, DWP has hired outside attorneys and outside consulting firms to scrutinize our data to the nth degree. But in every single instance, the district has prevailed because we have taken the time and the effort to be careful about the collection of our data, to document our data, and to ensure that it is completely reliable, consistent, and defensible. So, in conclusion, in 2000, the dried lake bed of Owens Lake was the largest single source of particulate matter pollution in the country. But as a result of the innovative data collection program, the outstanding effort by a small group of data collectors and analyzers, Great Basin has conclusively shown why the dust emitted, where it's emitted from. This has allowed the district to only order controls on the areas where they are necessary. And this will result in control of one of the largest sources of air pollution in the world. But without the dedicated field people, the people on the ground that collect the first set of data, none of this effort would happen. None of this would have been successful. So, thank you all for your hard work. Waiting for questions till the end. Is that right, Patrick? No questions now? Okay. Does anybody have any questions about presentation?
I just wanted to know how you, when you get such high levels of PM, obviously things like the standard high volume sampler can't cut it. You're going to get a cake on that thing an inch thick. So
that's exactly.
Do you run a bunch of them and run like every 4 hours or something?
We run the TOMs. At all of those locations where we have TOMs, we for about 10 years we had co-located parsols with them. The highest hourly concentration we measured so far with a TOM was 62,000. Now the TOM, and frankly, nobody knows if those systems actually are collecting accurate data at those levels. All we can say is, well, that's the minimum concentration that was in the air at that time. We've contacted the manufacturers to talk to them about it. EPA only tests up to 500 micrograms per cubic meter concentration at a speed of about 15 knots. That's it. So nobody's instrument gets tested at any higher level than that. So yeah, you could say it's an estimate, but it's probably a low estimate of what's actually out there.
So that's a lot of monitors that you're operating around the lake. And so my question is, how did you procure the funding to purchase those monitors and also to operate them?
Well, the Great Basin is in a very unique position. In the 80s, there was a Senate bill, SB 270, passed in the California legislature. It resulted in a specific addition to the California Health and Safety Code, Section 42316, which basically states that the City of Los Angeles will pay all of the costs of monitoring and mitigation development to the district every year. So in the old days when we cooperated with the City of LA, we would come up with a budget and talk with their staff about it and figure out what we needed to do and move forward. and they would pay the bill. But then when we finally promulgated the SIP and all that, then the fight kind of began. And so sometimes they pay, well, now they have to pay because it's been through litigation. But because of the legislation, they have to pay their fee every year. That's how we're able to do it. Thank you for your attention.